All right. So, uh, you can follow along with me if you like. Uh, but this is the one projectile motion problem that I'm going to give you. Okay. Listen, for brevity's sake, we don't have time to go into more depth. Okay, but this one's on page 64, and it's example 3-9. Okay, so if you want to follow along, it's up to you. If you don't, it's up to you too. All right. So, problem says, suppose the football in example 3-6 was punted and left the punter's foot at a height of 1 meter above the ground. How far did the football travel before hitting the ground? All right. So this is a continuation of example 6. Yeah. All right. So, problem is essentially talking about a football being kicked, right? So, just to go through the problem-solving procedure, right? So, it says how far did the ball travel before hitting the ground, right? So, how far did the ball travel? That means we're looking for what? Distance. Good. Distance. X. And then we're looking for it in meters. Okay? All right? And our second thing, right, we always decide on the time interval, which is in seconds. Okay? And then 3, we're going to talk about a diagram, right? So we got a little stick guy, right? And he's going to kick the football from here, right? And here's the ground. And they said he's kicking the football from here, right? And so we take this to be y equals 0, then down here is what? Y equals minus 1 meter. Everybody following that? We take this to be the 0, where he kicked it from, then the ground represents what? Negative, below the 0. Now follow me? Okay? So he kicked the ball, and it, right? That's what would happen if we kick the ball, right? So we are concerned, right, about what? From here to here, and that represents what? X. Right? Okay. That represents X. Right? So then, what do we need in order to solve for X? If we already know, well, do we know the initial speed? Did they tell us the initial speed? I think they did, right? So we didn't go through, so we got to go through the givens. So, all right. So, and that goes back to page 62, which is example 3.6. It says the ball was kicked with an initial speed of 20 meters per second and at a theta of 36 degrees, right? So then that means if I draw an imaginary Cartesian coordinate system here, then that means, well, not right there. Well, yeah, you can draw it right there, right? Well, I would want to draw the origin right there, from where he kicked it, right? So if I draw a Cartesian coordinate system starting from right here, right? Then that would be our what? V naught, right? Y'all following what I just did there? So this is the vector that represents the speed of the ball. And that's 20 meters per second at 36 degrees, right? So this is what? 36 degrees. So that's what we've been doing so far, right? So now you're taking the Cartesian coordinate system and you're applying it to a real life situation. Right? We've been doing this so far, right? We've had a Cartesian coordinate system and we had one vector, we had another vector, and then we had another vector. And then we added them all up together and did different things, right? Now we're using that same concept, but applying it to an actual problem. Okay? So, if I know my initial speed, right? Because I have an initial speed, VO. And what VO is a vector, so it has what? What do we know about vectors? Two components. This is the what? The what? I can't hear you. X component. So this is what? Initial speed in the X direction. Then I have a what? This is what? Initial speed in the Y direction. Right? So how do I get my components again? How do I get the components? Don't nobody know how to get the components? Yes. That's not it though. That's not the answer. That's like, that's like a horseshoe answer, right? It's like close is good enough, but that's not the answer. So tell me, how do I get the components? So nobody knows how to get the components. You gotta say a complete sentence, folks. We are in college, y'all. You have to talk to me in a complete sentence. Talk to me like a person.
So, you would use the, I'm thinking, because,
Go ahead. You can be wrong. We can be wrong, man. It's fine.
Since I said we're using sign,
All right.
we're gonna use opposite and adjacent to find.
No, sign is what? Opposite over hypotenuse.
So we're gonna use,
So sine, hold up, sine of theta is opposite over hypotenuse. Now let's look at our theta.
so we use tangent.
Huh?
We're gonna use tangent, right?
Hold up, let's deal with this one first. So we got sine of theta. So this is theta right here, right? So then sine of theta, so the opposite is what? What is the opposite of this angle? Huh? The y component,
Yeah.
right? So that's what this is, right? So this be Vy right here, right? What's the hypotenuse? V.
Yeah.
So the y component is Vy equals what? Huh? V sine theta. Now you just plug it in, right? That's not incredibly difficult, folks. So we just took 2 quizzes last week on that. 2 quizzes. And I'm just gonna suspect that most people got those answers correct. But when we get to class and I ask people, it's crickets. I don't get it. All right, so how we get the x component? It's not, it ain't but one other one. Cosine, right? Cosine theta, right, is equal to what? Adjacent over hypotenuse. And that's equal to what? The adjacent side is this, right? That's the x component over v. So vx equals what? V cosine theta. So I have the initial speed in the x direction and the y direction. I have the initial speed in x and y. And that's going to be important when we get to here, right? Because in order to calculate distance, right? Let's go back to chapter 1. What 2 things do I need to calculate distance? Speed and time. Good. I'm glad y'all got that. 2 things I need to speed and time. So I already got speed. So now I gotta do what? Calculate time. And that's the hard part. Alright? Well, it's not hard once you know what's going on, but it takes you a few times to do it, to get it. Alright? So now we have, we're looking for distance, and we already said that in order to calculate distance, we need what? Speed and time. Right? We're gonna multiply the 2 together. Alright, we got the initial, right? So Vy was what? 20 sine theta, sine 36, and Vx was 20 cosine 36. So we got the initial speeds in the x and the y directions, right? Because in order to calculate the horizontal distance, we're gonna need which speed? X or the y? The x. So this is gonna be x, right? Because remember, in projectile motion, remember when I told you we break things up into x and y, and then we put it back together. Okay? So now we need to figure out, so we already said it, I already just told you, right? We need to calculate time. That's what we're looking for. Time, so we can eventually get distance, which is this horizontal distance here, which is the distance that the ball will covered, right? It says what? How far? How far? Yep. How far the ball traveled before hitting the ground? Okay. All right. So we need an equation, right? That's the step 4. Step 4 is the equation, right? And bless you. And I'm just gonna tell you it's gonna be the constant motion equation, right? Because whenever we kick something, right, it undergoes what? It experiences what? Gravity. Yes. Doesn't experience it the same way as if we just dropped it, right? That's called what? Free fall. This is called projectile motion. And what's the difference between projectile motion and free fall motion? In the simplest terms?
Two different forces.
Huh?
Two different forces acted on and
Not two different, well,
X and Y.
yes, right? In free fall, we just act in one direction. In projectile, we act in 2, sometimes 3. It can be 4 if it's spinning, right? That's when we get into space and stuff like that. That's why things in space do this. A lot of things in space spin. Okay? So yeah. All right, so we're gonna use the constant acceleration equation, except we're gonna use it in the y direction, right? Y equals what? Y naught plus v o y t minus 1/2 g t squared. Is that it? Yes, that is it. Right, so we just replaced the a here with g, and then we made this negative, because all right. Yeah, so. All right, so now we can start to, once we've identified our physics, now we can start to plug and chug, which I know y'all love to do so much. Plug and chug. All right, so what's y? What's y? Look at the diagram, y'all. What's y?
0.
Not 0.
-1.
-1. What's y not? 0. Right? And did we get answers for these up here?
VY is 11.76.
76,
And then V of X is 16.18.
16.18. And this is meters per second, right? Alright, so now we can do what? We can plug in, right? Let's plug in. Finish plugging in. Alright, we got what? -1 equals 0 plus 11.76, right? 11.76 meters per second, T, minus, excuse me, 1/2, 9.8 meters per second squared, T squared.
Why is it minus?
Because we have a negative gravity, right? So, this distance, so really what we're gonna do is we're gonna be, see that? See this distance here? Right here is what we really, let me see something. Yeah, it's negative gravity. That's the, so we're kicking the ball. When we kick the ball up, gravity pulls down on it. All right. So here, right, we can rewrite this as a quadratic equation. Right? Let's rewrite that as a quadratic equation. Right? So our quadratic would be what? Negative 4.9. Right? T squared plus 11.76 T. Right? Plus 1 equals 0, right? I just brought this 1 over. Right? Oh, hold up. All right. And because I think this is because, because we don't the quadratic equation is going to get messy with a negative number out front. I think you just multiply this by -1, the entire thing by -1, and it's going to change all of the signs, right? That's our quadratic equation. Y'all following me? Right? So we get from here, which is the constant acceleration equation. That's the one we've been working with all the time, whole time, right? We just replace the numbers with our givens from our diagram, right? And then we made a new equation right here, right? Y -1, Y not 0, VO in the Y 11.76, G 9.8. Right? Then I took this and I brought the 1 to this side. Right? So then that would make this positive, right? So then that would make -4.9 plus 11.76 plus 1, right? Then I multiplied the entire thing by -1, right? And that just changed the signs and everything, right? And what I do on one side, I do on the other side. It's all great, right? Negative 1 times 0 is 0. Negative 1. On this side, I changed all the signs. So now I have a quadratic equation. This looks like what? Ax squared plus bx plus c. Right? How do I solve that equation? What is it?
Talking about the big old thing, d squared minus
Yeah.
b squared minus.
All right. So solution to the equation is x equals b minus b, right? What? Plus or minus
Square root.
square root of b squared minus 4ac.
Yeah.
I think this is it, right?
2a, because I was like, that.
All right. So go ahead and plug those numbers in, and somebody tell me what my 2 times are. You should have two answers. Why? Why?
Square root.
Which means,
Different outcome.
huh?
I said it's gonna be 2 different outcomes.
Yeah. But why? That's just the fundamental theorem of algebra. A quadratic equation
Yeah, 2 different outcomes.
with nth degree has n number of solutions. Right?
Yeah.
So if it was 3, then what?
Be 3.
We'd have 3 answers. So why does it make sense for this to have 2 answers? No.
Because of the square root.
Well, let's just get the 2 answers first. Now see here, now it's becoming, your calculator is becoming crucial now, right? Because, of course, if you gotta break all of that up, then it gets really messy. Nobody got an answer yet? You stuck?
I got negative 13.07.
One of them is negative. One of them is negative. So that's you're on the right track. That's not the number, but that's you're on the right track. One of your numbers should be negative.
if you were asking me step two, this is, to quadratic, 2.53 seconds for negative 0.081 seconds.
Yes. Yes, sir. Yeah, you can keep it open. You're coming back. You going back after your class, right? Okay. Okay. Yes, that's right. Good. Good. So T. So the answer to T has two solutions, T1 and T2. T2 we have 2 times, right? And T1 is, what was it? You said 2 point what? 2.53 what? Seconds. And what was the other one? Negative 0.08 seconds. Okay. So now show me. So now let's think about why are there 2 times. You're looking at the diagram, right? No? Anybody got a guess? Good guess? Good hunch?
Is it based off of the speed of how it's going in the y direction and the speed of it going in the x direction? Like the 2 different directions?
I mean, it is based on that, but it's much simpler than that. Like I think you're thinking about it too much. Right? So look, y'all. So look at right here. This is what? This is y equals 0. Right here. Does the ball stop right there? So where does the ball stop? Right here. Okay? So the number you actually calculate, right, is here. This time is here, and that negative number is this. Okay? So if, for instance, if we said, let me think of another example real quick. So if we, all right, so, well, I think we'll have to go through it, because I can't just say it and then you just understand it like that. I'd have to go through the math and all that and draw some pictures and stuff like that. But if this situation were different, and the guy, instead of the guy kicking it from 1 meter above the ground, let's say he kicked it, or he threw it from his shoulder, right? He threw it from his shoulder, and we made the ground be 0. And we made his shoulder be whatever height it is above the ground. Follow me? Then in that case, so I'll just draw a little picture over here. Maybe it might help you a little bit to understand what I'm saying. So if I said, so imagine if the guy was here and he and he did this, or we can just keep it the same way. We can just keep it the same way. Let's say he kicked the ball from 1 meter above the ground, but in this case, we're gonna make the ground 0, right? We're gonna make this y equals 0, and we're gonna make this y equal 1 meter. Positive though, right? Then when I kick it, it's gonna go like this, right? Bop, right? When I do my quadratic equation, I'm still gonna get a positive and a negative number. In that case, my positive number is here, and where's my negative number? Huh? Underground? No. No. Look at it. Look at it a little closer. So imagine, huh? Where would be my negative number? Negative is like imaginary, y'all. Negative time, it don't even exist, right? So where would be my negative number here? My negative time. So if I had a recording of this guy kicking the ball and I hit it and rewind, my negative would be this. Before he even kicked it. You following that? Well, I know you following that. You said it, right? But that would be my negative if I made y equals 0 the ground. You see, the difference here is I didn't make it the ground. We made what? Where he kicked it from, the 0. So the negative part is this part right here, right? But here, when I make y equals 0 to ground, then my negative part is here. It's like rewinding a tape. Like if I videotape this guy kicking the ball, and then I could somehow rewind it before he actually kicked it. Got what I'm saying? That's imaginary time, which doesn't exist. That's why we never take that answer in our stuff, right? So in the previous problem, when you calculated 2.53 seconds, and I'm thinking in that case you're gonna add those two, right? To get the total time. And then, let me see. Let me make sure before I tell you something wrong. Well, I guess that's point oh, is it 0.08? 0.08. Alright, so it ain't really that significant, okay? So you could just take the 2.53. Alright? So then we gotta get back to the answer, right? What was our answer? That's what we're looking for, right? Distance. We just found what? Time. So now what? Huh?
Multiply the time by the,
And what is the time?
2.53.
So I multiply, so now I'm at what? X is equal to V times T, right? And V is what? We erased it. V is what? What was it, 16 point something? 16.18. Remember, you can't use the same V, right? Because now we're talking about horizontal. So we gotta use VO in the X. Here we use what? VO in the Y. So you gotta pay attention to that stuff. Right? On this equation, we talked about Y and G. We use VO in the Y. But now we're talking about horizontal distance. So we're gonna use VO in the X. So the 16.18 meters per second times 2.53 seconds. And what's that answer? Like 39? 40 something? Okay, 40 meters. Okay, so the guy, so I don't know. I got soccer players in here, right? It's 40 meters. And kick a ball 40 meters.
Yeah.
Okay. That makes sense. Good. I wouldn't know. But yeah. Okay? So, this is projectile motion, folks. All right, so we only gonna, I'm gonna save y'all the, the heartache, and we're gonna only deal with this for the test and the vectors. Okay, we're gonna do vectors, and we're gonna do this, the quadratic equation. We're gonna make it real simple and plain. Okay? That's what you're responsible for in chapter 3. Vectors, what we've been doing all last week, and this. Now we're in chapter 4. We're done. You said, can you make them up? What happened to you?
They had us doing, they pulled us out of class and kept out there Friday.
Oh yeah, you're on the football team.
Yeah.
All right. What you want? What you got?
I was just gonna say for the lab reports we posted, the in-person one, I wasn't here when you were doing that because I remember I told you that I had an obligation. I could email you like my excuse, but yeah. So will there be a way for me to submit my lab report,
Well, we'll
or
do
would I
it.
get it from someone, or
Well, no, you gotta
it
actually
has to be like okay?
in person. You have to do it.
So should I come tomorrow, like early?
I have excuses for it.
So both of y'all missed the lab.
Yeah.
You too?
No, I missed the quiz. I sent you an email, but I don't know if you saw it. I don't know what you want me to do.
Okay.
Is it possible to take it tomorrow? Because I'm not doing
Quiz?
Yeah,
Yeah.
I guess.
Tomorrow. What's tomorrow?
Tuesday. I can take it anytime tomorrow.
Oh, well. I mean, I don't know if you're gonna be able to find me, like track me down. Like you can just do it Wednesday.
Gotcha.
Yeah.
Okay, I did mine Wednesday too.
All right.
Yeah, that was the same thing for me.
Okay.
So for the lab, like just come tomorrow for the regular lab time.
Yeah, but we're gonna have another lab tomorrow.
So you want me to stay after the
So
class,
after
or like?
come earlier.
Well, no, I think we're gonna have to just do it a whole nother day.
Well, that's fine.
Yeah,
Okay.
yeah. So
Come
tomorrow
on
we
that
got
Thursday
another.
for the recreation.
Say it again.
Come on Thursday for the recreation.
Recitation.
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 Presentation. Well, that's not lab, so we won't do any labs. On
So should we come that day just to make up that
To make
the
up.
one that was missing, or?
I mean, y'all can. So
Okay.
y'all.
Okay.
Yeah,
I'll
we'll do
come
that.
on that day to make it up.
Thanks.
All right.
I was supposed to take the quiz today, but I'm guessing I'm taking it on Wednesday with everybody else.
Which quiz?
The one on Friday, I had to go out of town, and I emailed you so I could take it on Monday. Today.
Oh, okay.
Yeah.
All right.
So
Which
just
quiz is that?
Wednesday. It's the most recent one on vectors.
Oh. Oh, okay. I just made that up. So all right. I just make something up on.
Okay.
Okay. All right.